The next thing we want to consider is we might want to initialize our fields. Now, as I said before, fields of an integer type are automatically initialized to 0. So you could do this like so. That's a no-op. I mean, that's exactly what was there before by definition. But let's just say that for the sake of argument that no cars actually ever start off at 0 miles. I've never actually seen a car where the odometer is all zeros because they bring them off the truck or the ship or wherever they come from, and they have to drive them from point A to point B to get them to the dealership. So let's say that number was, really doesn't matter. Let's say it's 4. All cars have to have at least 4 miles. So there's an example, and I'll add otherwise. There's an example of initializing a field, because that's a pretty simple one. It might be, however, that what you need to do to initialize your class is a little bit more complex than that. And so that's where constructors come in. So let's actually create a constructor like so. Constructors are sort of strange little, they look like methods, but they're not exactly methods. The details of this have to do with the current object, which we will talk about later. But for right now, the name of a constructor is the same as the name of the class that you're in. Okay, so here I have the car constructor. And just like methods, constructors have access specifiers. So I'm going to say that this is public because I want people to be able to see it from the outside. It certainly does make sense to be able to create a constructor that doesn't present itself to the outside. In other words, one that's private. We just don't have a need for that here. So I'm going to say public car, and I'm going to put the empty set of parentheses and a block statement. Okay, so there's my constructor. It takes no parameters. This is the parameter class constructor. And in fact, the word constructor is so long you will often see constructor abbreviated to CTOR. Okay, so all constructors, you just call it CTOR. That's not the parameterless part that I'm just showing you. This one doesn't have any parameters. And so then I could, in this case, I could initialize my field like so. And just to make it different, I'm going to set it equal to 10. So now we have 2 places that you've got a field and it has been initialized. So here I've initialized it to 4, and here I've initialized it to 10. So then the question is, which one takes precedence? All right, well, let's actually go ahead and walk through that code again. So F11. And there we go into the constructor here. You see actually a call to it. And there it says mileage, and before that code is actually executed, mileage is 0. I execute that line, mileage becomes 4. You can see that here. It's kind of small, but actually there's a 4 there. And then I go ahead and execute the constructor, which we will then re-initialize, if you like, mileage to be 10. Okay. So the answer, about which one takes precedence, you can have more than one place that a field is initialized, and essentially what takes precedence is where it's initialized in an actual constructor. So it'll be equal to 10. And we can see that fairly easily. I'll just go ahead and run this. And there you can see that instead of being 100, it's 110 because we had those original 10 miles, and then we called drive and drove another 100 miles. What I want you to notice, though, is that I'm once again accessing a field directly rather than using its associated odometer. Now, in this case, again, it's a piece of trivial code, but as things get more complicated it's more important to make sure that you know what's happening and when. I would suggest that rather than saying mileage here, you say odometer. And so then, once again, that means you're executing the property code, which is going to make sure that you don't do something that you don't want to do with the field. In other words, this protects, so using the property protects the validity, TY, of the object. In other words, we want to make sure that anytime we change the data, we do all the testing to make sure that that change of data is an appropriate, a valid change, and it doesn't somehow mess up the object. Going back to main here, we don't really see much of a change there because this is where that constructor got called. So this is actually invoking the constructor, CTOR, like I said before. All right, so then what was happening before we actually created this code? All right, so we didn't write this code, or this code hadn't been written, and yet we were able to invoke the constructor. In other words, we were able to say new car, no parameters. Well, it turns out that if you don't have, and I'll just put this up here, if you don't have a parameterless constructor, the compiler creates a default constructor. And what does the default constructor do? Basically, that's the thing that makes sure that all the fields of a given type are initialized to 0 unless they have a specific initializer. So you can just basically think of it as being an empty constructor, and it really doesn't do anything, but it allows you to create objects, because without it you can't create the object. So if there's no, oh sorry, you don't have a parameterless, sorry. If you don't have a parameterless constructor, the compiler creates a default constructor. But once you create that parameterless constructor, which is this thing right here, then so once you create your parameterless constructor, the default constructor is overridden. Which basically means the compiler doesn't call it anymore because you have something of the same signature, in other words, the same calling pattern. The compiler's version is ignored, essentially. All right. However, it is possible that you might want to have more than just a parameterless constructor. So just like you can have methods that have parameters, you can have constructors that have parameters. And in this case, all we really have is mileage. So I would say something like int initial mileage, like so. And that would say odometer. Again, you could use the field underscore mileage, but probably not a good idea, is set equal to initial mileage. I suppose theoretically that could be a problem because you've set it here to be 4, and if you called this constructor with a number that was less than 4, this call wouldn't do anything. But again, that's what we want. If for some reason the car has more mileage on it than that, you sort of have to allow for that possibility. But another possibility is to not initialize it there at all and allow the construction of the object to take precedence, which is to say allow the people that call this method to decide exactly how many miles it has on it. Which, by the way, could also be, actually no, it couldn't be less than 0 because we're initializing it to 0 and we're not allowing it to get any smaller. Okay, so now that I've got this new constructor that allows me to specify my initial mileage, I can go back here and create a second car. So let me put that after this one. So I could say car Maverick equals new car. And this is a little bit different. I want you to notice with Pinto, I created the variable. Okay, so Pinto is what's called a reference variable because it points to something. In other words, if you remember to go back to the picture we had, Pinto itself is just something that points to more storage, right? So that's what's known as a reference variable. And at this point, it doesn't really have a value. It's not until we do this that an actual object, as we think of, is created. I put that on 2 separate lines to show you that that's one possibility. There's your reference variable, and there's your instantiation. So when you invoke the constructor, that's instantiation. Okay, so I could put that in one line like this, and because I have a constructor that takes a parameter, I could say my initial miles, let's say this is a used car, is 54,321. And then, of course, you can write that out. so, and then I'd put in Maverick dot odometer. And then I could, for whatever reason, decide to drive my car. So drive, and I've got my parameter there. I'll take the one that I'm going to drive at 250 miles, let's say, and then write out a new statement. All right, so let's run that. And I think it does pretty much what we would expect. My old car has 54,321 miles on it. Now it has 54,571 miles on it because I drove it 250 miles. So in other words, that's exactly what we'd expect.